To all panel members, our subject teacher, and our advisor, good afternoon. I am one of the researchers, Austin Josel and Lumbis, and we are here to present our thesis entitled Offshore Vessels Automated Fire Notification System Using Raspberry Pi and GPS Module. I will be discussing chapters 1 and 2 for chapter 1, Introduction. In this chapter, I will be discussing the background of the study, statement of the problem, significance of the study, scope and delimitations, research paradigm, and definition of terms. Background of the study. Fire at sea is entirely different from fire ashore. If you escape from a burning building, you are already sheltered. But when you escape a burning boat, you are still in the middle of the sea and most probably very far from land. Ships on fire have caused millions of deaths around the world. An example of this accident is involving MV Maria Carmela, a vessel that sank after it caught fire last April 11, 2002. Fire broke out around the vessel at 7:30 a.m. that day and was burning for 3 days until it sank in Pagbilao Island. Similar incidents also happened in MV Viva Antipolo 7 and MV. On foreign seas, the SS Moro Castle caught fire and burned, causing the deaths of 137 passengers and crew members. It runs between New York City and Havana, Cuba, in 1930s. This catastrophic fire aboard the SS Moro Castle was a catalyst for better fire protection aboard the ship today. Similar major accidents also happened on the MS Scandinavian Star and TSMS Laconia. The Philippine Coast Guard. Philippine Coast Guard is a uniform service in the Philippines which mainly focuses on everything that happens on the shore. They are basically the police officers of the sea or can also be the ambulance of the sea. On past issues, the Philippine Coast Guard had been involved in many accidents due to their negligence, shortness in effort, lack of training and equipment, and mostly because of their slow response time during these incidents. Fire Detection and Alarm System. Fire Detection and Alarm System, or FDAS, serves as the notification system of industries in preventing fire from spreading all throughout their establishment. It consists of different kinds of detectors varying on what specific requirements is needed. Then it notifies by the use of warning sirens, horns, bells, lights, or combination of these. Current technologies in fire detection on vessels include infrared flame detection, photoelectric smoke detector, ionization smoke detector, and overheat detectors. Statement of the problem. Our main objective is to design an offshore vessel's fire notification system that can automatically notify the nearest coast guards on its exact location once the FDAS has been activated. The specific objectives are as follows. To design a system that can be integrated with the existing FDAS, to develop a system application that can automatically notify the nearest Coast Guard station, to identify and utilize appropriate microcontroller unit and GPS tracking module, to develop a prototype vessel's fire notification system utilizing the current FDAS setup, and to test and evaluate the functionality of the overall system prototype. Significance of the study. For marine institutions, this aims to further improve the FDAS of all the maritime ships that is available today. For seafarers and passengers, this aims to reduce the panic aboard the ship and for them to increase their survival rate. To the Philippine Coast Guards, this benefits them to improve their response time in order to save and lessen the casualties aboard the ship. And to other developers, this may help inspire them to improve our study and innovate the fire detection and alarm system. Scope and limitations of the study. This study will focus on designing an automated notification system on vessels only to improve the vessel's current FDAS. The system is only limited on vessels that has FDAS installed. The system will only work when it is connected to the internet. The prototype is only restricted on vessels that has a control or bridge node. The system should operation coordinates will only be sent by email. The system is only limited within the Philippine area of responsibility. Prototypes used, such as the certain microcontroller, the fire alarm system, GPS module, Wi-Fi router, will be outsourced. Only the automated notification system will be the concern of the researchers. This is the conceptual framework of our study. Input, F dash, current vessels FS technology, microcontroller unit, system components, test instruments, and application software. In the process, first we analyze the existing system, reconfigure the existing system, prototype development, programming, and then system prototypes, test, and evaluation. And our desired output should be the offshore vessels automated fire notification system using Raspberry Pi and GPS module. Chapter 2. Review of related literature and studies. These related literature and studies are what helps us in our development of the thesis. First, design of a study helps us a lot because of the similarities between the studies. The difference is that they have used Arduino Uno as their microcontroller unit, and ours, we used Raspberry Pi 3. Second, remote multifunction fire alarm notification system based on Internet of Things. This study helped us in determining on what kind of microcontroller is best used for Wi-Fi applications. Third, real-time alarm, dynamic GPS tracking, monitoring system for man-hour robot. This research is about the use of microcontroller and GPS and GSM modules. It helps us improve our knowledge in how to connect the microcontroller and GPS module in the alarm system. Related research. Alarm system using microcontroller, GPS, and GSM modules. This research also helped us because of the similarities that we have, that we used a microcontroller and the GPS module. But again, they have used Arduino Uno and we have used Raspberry Pi 3 for our microcontroller unit. Second, microcontroller-based automobile tracking system with audio surveillance using GPS and GSM module. This paper presented a tracking system for automobiles using microcontrollers and GPS and GSM modules. This paper also helped us to improve the tracking system we have on our system using microcontroller and GPS modules. Third, GPS GSM based inland vessel tracking system for automatic emergency detection and positioning. This research helped us improve our system's automatic detection and position notification. Next. And to synthesize our review of related literature and studies, we analyze past studies and evaluate ideas from past researchers. The researchers have learned parts of knowledge that we will use to design a system that will automatically notify the Coast Guard station when an offshore ship or vessel's fire detection and alarm system became active. Some limitations have also been discovered by the researchers and will be avoided in future works. For Chapter 3, my co-researcher will be discussing it.
So good afternoon again, everybody. Good afternoon, panel. So this is Jester Maverick de Trinidad, one of the researchers, and I will be discussing the Chapter 3 of our research, which is the methodology part of the research. So this chapter presents the different research methods and techniques, basically on how we design the prototype, how we use different hardwares, combine them using microcontrollers, how we use the internet, how we send data on the cloud, and how we program on programming languages by coding, and just how we made the research itself. So first, I will be discussing the methodological framework. So this is basically the plot on how we create or how we are going to do our research. So first is designing the system. So this is the part where all our designs and plans are put into work, or basically on layman's term, put into paper. So this is where me and my partner, or my research partner, AJ basically talked and combined our ideas and explained how different hardwares work and how they are combined and how the microcontroller will help process information going to the cloud and different systems like that. So the second step is system components. So basically the components are the organs of our research. They are really important in our research because one component lost, the research may be broken or will not work anymore. Research components will be acquired mostly maybe after the defense because we know that we are on a pandemic, so we are having struggles, especially with the delivery, shipping charges, and like that. But most likely, all components will be acquired when it's time for us to create our prototype. So next one is coding. So this is the most very critical part of our research because this mainly focuses on the or what do you call this one? Main topic, which is the notification system. Because one wrong mistake or input in our coding, our prototype will be broken or cannot work anymore. So this coding really is a very essential part. Next one is testing and simulation. So we have created tables and different observations on different aspects of the prototype. Most likely, we will have remarks on every aspect if it's passed or approved. And then, probably if our expectations are met, then it will be good. And if not, if any of the expectations were not met and the remarks are failed, then we will proceed with the next part, which is rectifying errors and found in simulation. It means we will specifically find on where the error occurred, where the glitches are found, and what is basically the mistake we did, maybe in the wiring, fault of the component, or maybe in the coding. And then afterwards, after all are polished, we will do the final testing, and hopefully if our expectations were met, then we're all good. Prototype's okay. So next, I'll be discussing the flowchart. So this is really important because this is like the summary of our prototype itself, of how step by step it really works. So first, as you can see, we have our smoke detector, which is our main input. The input would be smoke. If there's no smoke, you can see the operation will not start. If there is, the fire alarm system will set, the bell will start ringing, the lights will turn on, and then the Raspberry Pi will be receiving information which is an analog signal from the fire alarm system. Now, and also, Wi-Fi signal will also be sent to the Raspberry Pi so that it will be connected to the cloud or to the internet, as well as the GPS module which will be connected to the Raspberry Pi so that it will give the exact GPS coordinates on where you are at this certain location. So in this part, which is, we put a time delay in our prototype. So basically this is what makes our prototype unique. We discuss mainly about this and then we come up with a solution for the false alarm mechanic. So that maybe in the Coast Guard there will be false alarm response. It will be a big mistake for everybody. So if there's a false alarm, we will have a push button, or we call it the termination button, which if that is pressed within the 10-second delay, the operation will not occur anymore. But if ever that there's really a fire incident and there is no false alarm, the Raspberry Pi will be sending data on the cloud or in the internet, and then the internet will send the GPS coordinates through email. And basically that's just how our prototype works. So next, this is our proposed prototype design. As I said in the flow chart, this one is the fire alarm system panel. It is connected to the transistor, which is a MCP 3008. which converts AC signals to DC signals. I'll be tackling that later more. Which is connected to the Raspberry Pi, and which is the GPS module, and the Wi-Fi is connected to the Raspberry Pi. Push button for false alarm, and then if there's no false alarm, it will send a link, and the link will put you in Google Maps. So this is basically the prototype setup. So there we will have a casing. Inside the casing, there will be the push button, the GPS module, and the Raspberry Pi. And we will just put that box on top of the fire alarm system so that the connections will not be disconnected in other ways. So yeah, basically that's just how we will set up our prototype. So the hardware component. So for our microcontroller that we will be using Raspberry Pi 3. Why did we use Raspberry Pi 3? Because Raspberry Pi 3, unlike the other microcontrollers, has a built-in Wi-Fi. And in case of costing, it costs less than other microcontroller. So we'll be using Raspberry Pi 3. The other one is the GPS module. So GPS module, it will be the one that will send data to the Raspberry Pi so that we will know where we are right now, the exact GPS coordinates and the location. So the next one is the fire alarm system. The other one is the MCP 3008. So as I told you earlier, the Raspberry Pi has the Raspberry Pi has a weakness. It doesn't read analog signals. The problem is the signal that the fire alarm system sends is an analog one. So we will use MCP 3008 to convert AC signals to DC so that the signal sent by the fire alarm system will be read by the Raspberry Pi. Then, of course, our Wi-Fi, which is TP-Link 300 Mbps high-power wireless network router. The next one is the software component. So we'll be using Raspbian, which is basically the OS of Raspberry Pi. New out-of-box software, which is the installation manager, or we call it Noobs, so that we can download softwares that we need. The other one is Python. This is the programming language that we will use. This will be the one that we will put the codes that we'll be needing into. The next one is test and simulation. So basically, this is where we observe, we experiment, we analyze, we check for limits of our prototype, we check for glitches, for errors, and this is just basically speaks for itself. We will test it and we will simulate it. Okay, the first one that we will test is the capability of the device to receive and send out exact GPS status information. Basically, this is just, we'll have 20 trials, and then we will have 20 different locations, which is 5 kilometers apart. What we are gonna do is, we're gonna operate our system in that location, and then we're just gonna see if the prototype will give the exact GPS coordinates. But of course, for margin of error, we will be having a 1 kilometer radius for every location. Okay, so next is the capability of the device to send out GPS location status instantly. So what we're gonna do is that we will measure. Basically, we have a time delay of 10 seconds. So we're gonna measure of how long will it take after the time delay for the receiver to receive the data, which is the link, which is the status location. So that's just basically it. So we will have 20 trials, and we have a margin of error of 5 seconds. So it shouldn't be 5 seconds or more, because if it exceeds 5 seconds, the remark will be failed. And what we have here is, on every trial, we should have 100% passing rate on the remark. And if ever that it is not 100%. Maybe we'll go back to fixing glitches and errors on what mistakes we had. So the third one is the time delay capability of the device to keep the location status pending until a certain amount of time in case of false alarms. So in this one, we will be just measuring our time delay because we set up based on the programming, a 10-second delay. So we will just be measuring or recording the time it takes for the device to hold its data until it sends. So basically, it's just measuring the time the time delay itself. So we will have 20 trials, and just like the others, remarks should be perfect, 20 over 20, for it to be redeemed working. So the last one is the capability of the device to prevent its operation from performing its function when the termination button is pressed. So basically, this is just for the false alarm. This is a very crucial part because some researchers have created similar studies, but they have not tackled about the false alarm itself. So basically, this one, we will test if the push button is accurately canceling the operation 100% when it is pushed. So what we're gonna do is we will have 10 trials, and the termination button will be pressed 10 times from every second, from 1 second to 10 seconds respectively. So we're gonna push it on 1 second, 2 seconds, until 10 seconds. And we will gonna look if it will stop the operation. So as well as the others, the remarks should be perfect for it to be redeemed working. So 10 over 10. So this is gonna be our estimated project costing. So 15,995 all in all. So as you can see, that's gonna be quite heavy. So this is our Gantt chart. So basically, this is all we did this sem. With our research, we put really a lot of efforts into it. And you can see, we have accomplished everything only first week of June. And we really had hard time, but we really had fun because we had brainstorms and ideas merging together. That's it. So this is our references that helped us in our study. So basically, that's it. So again, I am Jester Maverick de Leon Trinidad.
And I am Austin Jocelyn Lumbis.
So this is our research overall. So thank you for listening, and God bless you all.